Welcome to another video. Calculate the shaded area. So today we have a typical trigonometry equation combined with the angle properties of a circle. So I'm going to take you through the properties up to the end and also solve for the required region and the shaded area ACD. I hope you're able to see it clearly. So I'm going to take you through step by step up to the final solution. If you're watching us for the first time, kindly remember to subscribe, like, and leave a comment. Let us dive into the solution. If you look at this, I have a semicircle A, B, C, D, and a given triangle ACB or ABC inside that semicircle. So my first step, look at triangle ABC. It is an isosceles type of triangle. And we know that isosceles triangle, the bases are always equal. So for me to get the unknown angle B, I'm going to take the sum of interior angle of a triangle, subtract the bases, so that I'm going to take 2 times 25. Doing that, I'll get angle B as 130 degrees. So that is my first step. So that means here I'll have 130 degrees since it is an isosceles triangle. So well, step 2, if you look at ADC, AD is our diameter, and it goes without saying that if you have the diameter, it subtends a given angle at the circumference. So when I join C to D like that, I'm ready and easy to see that the diameter subtends a given angle of 90 degrees at the circumference. So it subtends angle 90 degrees at the circumference of any given circle. So that means angle ACD goes without saying that it is 90 degrees. And we are being given that radius is 3 centimeters. And the diameter will also be 6. So if I complete ABCD, it forms a given quadrilateral. And if this circle was complete like that, then this ABCD could be a cyclic quadrilateral inside a given circle. Since a quadrilateral is a 4-sided figure, and another property guiding the quadrilateral inside a circle is that the opposite angles opposite angles in a cyclic quadrilateral should add up to 180 degrees. Meaning, if I take this angle C and angle A, I'm sure I'm gonna get 180 degrees. So for me to get this angle and known value X, of course I'm gonna add this plus this plus this and then subtract them from 180 degrees. So that I get the value X, and the rule is guiding me that the opposite angles of a cyclic quadrilateral add up to 180. Solving this, I'm gonna get the value X as 40 degrees. So that goes without saying that that is 40 degrees. Next step, we are given that O is our center and AO is our radius. AD is also our radius. I can try joining O to C so that this also becomes my radius 3. So it is forming some two given shapes. I'm gonna call this one A, that one 2. That is first and the second area. Meaning I'm gonna calculate area 1 and area 2 separately to get the total area. If you look at triangle AOC, since this is 40 and this is radius, then it also forms as an isosceles triangle. So the other side means it's also going to be 40. So for me to get angle AOC, I'm pretty sure you're able to see AOC, then I'm gonna take 180 degrees minus twice the bases, so that I get here as 100 degrees. So well, on the other side, I'm gonna calculate angle Y. So well, now calculating angle Y, this one, I'm gonna consider it as angle COD, and this angle is in a straight line, on a straight line. If this is 100 and angle Y will be equals to 100, 180 minus 100 to get 80, as the angles on a straight line add up to 180. So it goes without saying that angle Y is 80 degrees. So well, I can remove out the first sector So if you look at COD, it forms a given sector like that. So that is O, and that is 3, and the angle inside there is 80 degrees. So I'm going to calculate this area using angle subtended at the center over 360 times pi times r squared, meaning the radius squared. Solving it, the angle subtended will be 80 over 360 multiplied by pi multiplied by 3 squared. Of course, my pi, I'm going to use this as 3.142. And when you have a nice calculator or a scientific calculator, computing all these together, you're going to get area as 6.283 centimeters squared. So that is the area of the first part. This one, it forms a given sector. And the area of the second part, the other one, it is forming a given triangle. And when I pull it out, I'm going to get a given triangle looking like this. So that is 3, 3, and the angle included is 100 degrees. I'm going to solve this triangle using the sine rule, which tells me that area can be calculated as a half a multiplied by b times the sine of c, which means the angle included in that triangle. So solving it, I'm going to get a half times 3 times 3 times the sine of 100 degrees. Computing that in my calculator, I'm going to get the area as 4.5 to the sine of 100. So computing this 4.5 times sine 100, you're going to get 4.432 centimeters squared. And the total area, meaning I'm going to add area 1 and area 2, so that I get the total area as 10.715 centimeters squared as the required area for this shaded part ACD. So guys, we have come to the end of this question. Don't forget to subscribe, leave a comment, share. Until we meet again in the next video, goodbye for now.